So we're continuing with 1B, still talking about complex numbers. So on Thursday, we used the imaginary unit I to write complex numbers. Friday, we did adding, subtracting, and multiplying. And so today we're doing the last learning target, which is to use complex conjugates to write the quotient of two complex numbers. So we're going to be doing dividing. Okay, so to divide complex numbers, when there is an imaginary number in the denominator, multiply top and bottom by the complex conjugate of the denominator. Okay, so make sure you write down what we do to divide. To divide complex numbers, we're going to multiply top and bottom by the complex conjugate of the denominator. Multiply top and bottom by the complex conjugate of the denominator. We use that word conjugate in R1 when we were talking about rationalizing radicals. We had a radical in the denominator. So it's similar here, but it's just with complex numbers. So for example, probably want to write this down as well. If a plus bi is our complex number, its conjugate is a minus bi. So that's what we mean when we're talking about a conjugate. So you probably want to write that down as well. A plus bi and a minus bi are conjugates. So notice the a and the b, the numbers are the same, but there's the opposite sign in between. One has a plus and one has a minus. Okay. So we're going to do 2 examples, and then we'll do a practice problem, and then we'll do one more type of example. So write down number 16. Here's the example. 2 plus 3i over 4 minus 2i. So write that one down in your notes. 2 plus 3i over 4 minus 2i. Okay. What we're trying to do here, this fraction bar means we are trying to divide this. But I don't actually divide anything. I'm going to multiply by something. The problem with this that we don't like is that it has a negative, or sorry, it has an I in the denominator. And remember, an I is a square root of -1. So this means it has a radical in the denominator, which we don't want. So somehow I have to get rid of the I in the denominator. So what we're going to do is we're going to multiply both the top and the bottom by the conjugate of the denominator. I like to put both the top and the bottom in parentheses to help me multiply correctly. And now I'm looking at the denominator, the 4 minus 2i. I need to figure out the conjugate of that denominator. So if this denominator is 4 minus 2i, the conjugate is 4 plus 2i. So I need to multiply by the conjugate. Now, if I multiply by 4 plus 2i in the denominator, I have to multiply by the same thing in the numerator. All right, so that means I'm multiplying both the numerator and the denominator by 4 plus 2i. All right, when I'm doing my algebra, I'm going to do the numerator and denominator separately, but we just got to make sure we put our answer together when we're done. All right, so let's do the numerator first. So in the numerator, I'm multiplying 2 plus 3i times 4 plus 2i. So I'm multiplying the numerators together. 2 plus 3i times 4 plus 2i. So this is why we need to be able to do multiplying. So you can either use box method or distributive property. Well, they're the same thing. So I'm just going to do the distributive property here, just mostly kind of to save a little space. So I have to distribute this 2 to both of those. So 2 times 4 is 8, and 2 times 2i is plus 4i. Then I have to distribute the 3i. 3i times 4 is plus 12i, and 3i times 2i is plus 6i squared. Now to simplify this, I need to simplify the I squared. So we have to remember that I squared is -1. So this last term, the 6i squared, becomes 6 times -1, which is a -6. So I simplify the I squared, then I can combine like terms. So combining now the real parts, I can combine the 8 and the -6, which is 2. And I can combine the 4i and the 12i, which is plus 16i. Okay, this is not my final answer. This is only the numerator. So keep that in mind. We're not done yet, but we are halfway done. All right, so that's what I get in the numerator. I multiplied 2 plus 3i times 4 times 4 plus 2i and got 2 plus 16i. All right, now let's do the denominator. Then we will put it together. So in the denominator now, I am multiplying 4 minus 2i times 4 plus 2i. So notice we're multiplying the denominator by its conjugate. 4 minus 2i times 4 plus 2i. So same thing, let's go ahead and distribute and simplify that. So I'm distributing the 4. 4 times 4 is 16. 4 times 2i is plus 8i. And then I am distributing the -2i right here. -2i times 4 is -8i. And -2i times +2i is -4i squared. So we distribute. Then we simplify the I squared. So this last term, -4i squared, can simplify. I squared, remember, is -1. So this term is -4 times -1. And a negative times a negative would become +4. So now if I combine like terms, I'm combining the 16 and the 4, which is 20. Now notice if I combine the i's, 8i and -8i, that adds up to 0. So when I multiply a number by its conjugate, notice we just end up with a real number. Okay, this is the denominator. So we multiplied the numerator and we multiplied the denominator. Now I actually am going to put it together. Because remember, our answer, this is the numerator and denominator. It should still be written as a fraction. So I'm going to write it like this: 2 plus 16i over 20. Two plus 16i over 20. So I just put the numerator and over the denominator. If you left it like this, that is correct. It means you did all your multiplying correctly and everything. This can be simplified though. So I want to talk about a couple ways we can simplify this. The way it's written right here, 2 plus 16i over 20, you might notice all these numbers, 2, 16, and 20, have a common factor of 2. So you can divide out a 2 And that will reduce all of them, but leave one fraction, like one single fraction. If I did that, 2 divided by 2, this would be 1 plus 8i over 10. Notice it's still written as one fraction. The whole thing is still over 10, but it just happens to be reduced. So these are equivalent. The third way you could write this is you could divide each number in the top by 20 separately and then reduce separately. So if I did 2 divided by 20, that would reduce to 1 over 10. And if I did 16i divided by 20, 16 over 20 would reduce to 4 over 5. So that would be plus 4i over 5. Okay. So again, it doesn't really matter which way you write your answer because all 3 of those are the same. Usually we do try to simplify if we can. So the second or third answer are better because they're simplified. The third answer though, this is the only one that's actually written in the form a plus bi, because there's the real part and the imaginary part are separate instead of one big fraction. But again, like I said, if you typed any of those answers, you would get the full points because that means you know how to do the problem. However, it's good to recognize that these are all the same. Okay, so that's what multiplying looks like. We're not actually multiplying anything. That's what dividing looks like. We're not actually dividing anything. We're multiplying by the conjugate. All right, we're gonna do one more example with multiplying and then we'll stop and do some practice problems with the dividing. Okay, so write down the next example, number 17. On 17, we're trying to divide 6 plus 4i divided by 2 plus I. 6 plus 4i over 2 plus I. All right. So I am dividing by a complex number, but I'm not actually going to divide anything. I'm going to multiply by something. So look at the denominator. The denominator is 2 plus I. So if you think you know what I have to multiply by, type it in the chat to everyone. What am I going to multiply by if the denominator is 2 plus I? Good. So Jenna, Debony, Brian, Jacqueline, Livna, they all have the correct conjugate. We're actually going to multiply by 2 minus I. And if I multiply, I have to multiply both the numerator and denominator by 2 minus I. Okay, like the previous problem, I'm going to multiply the numerator and denominator separately. But the first thing is just make sure you're multiplying by the correct thing. All right, the numerator. So this is just the numerator. I'm multiplying 6 plus 4i times 2 minus I. And if you prefer, you can use box method. The previous example, I did not use box method. This one, I'm going to show the box method, but you don't have to use, you could use whichever one is more comfortable for you. All right, so I'm multiplying 6 plus 4i times 2 minus I. So in my boxes, this would be 12 plus 8i. This lower row here, the bottom would be negative 6i. And then negative I times 4i would be negative 4i squared. Okay. Then I'm going to simplify the I squared. This I squared can be replaced with -1. So this box here, sorry, it's kind of hard to read all that, becomes -4 times -1, which becomes +4. So now if I combine like terms, I have the 12 and the 4 that can combine. So that gives me 16. And then I can combine the i's. 8i and -6i is +2i. Okay. So that's what we have in the top. 16 plus 2i. I'm not done though. That's not my final answer, because that's only the numerators multiplied together. Now I'm going to multiply the denominators together. So I'm multiplying 2 plus I times 2 minus I. And for this example, I'll show you what it looks like with box method. So 2 plus I times 2 minus I. And that's going to give me 4 plus 2i. This box will be minus 2i. And then this bottom corner, -i times I, would be -i squared. Okay, then I got to simplify the I squared. -i squared, remember I squared is -1. So this bottom box, the bottom right, becomes -1, since it was minus I squared. And so that's going to become a +1. And then the +1 can combine with the 4, and we get 5 for the real part. For the imaginary part, 2i and -2i. Notice those should be opposites because we had conjugates, and they should always add up to 0. So in our denominator, we just have a 5. So the 16 plus 2i is the numerator, the 5 is the denominator. Okay, so when I write my answer, I do have to just I have to write it as a fraction with this in the numerator. So I'm going to have 16 plus 2i over 5. So notice it's still a fraction, but there's no longer an I in the denominator. The other way you could write this is by putting each term in the numerator over 5 separately, like this, 16 over 5 plus 2i over 5. This one doesn't reduce. None of the fractions reduce, but this is how we would write our answer on number 17, either this way or this way. Neither is wrong. Usually, I don't care which way you write it, but the second way is actually written as a complex number because it's got the real part and the imaginary part separately. Okay. Okay. It says number 16 again. My numbers must be off somewhere, but just write down that example. So we have 2 minus 3i times -4 plus 5i plus 3 plus 6i. That's all in the numerator over 2 minus 7i in the denominator. All right, so write that example down. 2 minus 3i times -4 plus 5i plus 3 plus 6i That's all in the numerator over 2 minus 7i in the denominator. So as you can see, this has several operations here. I see multiplying, adding, and dividing. Here is what we need to recognize on this problem, though. For order of operations, the fraction bar is a grouping symbol. So what that means is before I can do this operation, this division, that means I have to group the numerator together and group the denominator together. So in this case, I'm actually going to simplify the numerator first. Simplify the numerator first because that fraction bar acts as a grouping symbol. So in the numerator, I have two operations. I have multiplying right here, and I have adding. So in the numerator, I first would do the multiplying. So let's do the multiplying first. Okay, so this is just first working with the numerator. So in the numerator, I'm going to do the multiplying first. So I'm multiplying 2 minus 3i times negative 4 plus 5i. 2 minus 3i times negative 4 plus 5i. So I'm multiplying that. I'm going to use distributive property, or you could use box method. So I'm going to distribute that too. So that's going to be negative 8 plus 10i. Then I'm going to distribute the negative 3i. Negative 3i times negative 4 is plus 12i. And then negative 3i times 5i is negative 15i squared. Okay, so that's what I have after I distribute. Negative 8 plus 10i plus 12i minus 15i squared. Then simplify the I squared. Remember, I squared is negative 1. So this term here becomes negative 15 times negative 1, which becomes a positive 15. And then I can combine the positive 15 with the negative 8. I can combine the real parts. So that gives us a 7. And then for the imaginary parts, 10i and 12i gives us plus 22i. Okay. So that's what we have so far when we multiply this together in the numerator. Okay. Now let's continue with the rest of the problem. So that's this part underlined in blue, gives me the 7 plus 22i. The other thing I have in the numerator is I have this other complex number here, plus 3 plus 6i. Okay. So now I'm going to do the whole numerator, all this together by just adding these two. So when I add those two, I add the real parts and add the imaginary parts. Luckily, the adding part is pretty simple. So when I add those together, we end up with 10 plus 28i. Okay, so that's what the numerator simplifies to. So I did the multiplying, then I did the adding. Now, don't forget, we're not done yet. This is still over 2 minus 7i. So now that I simplified the numerator, now I can do the dividing. I can divide by 2 minus 7i. Remember, we're not actually dividing anything, we're multiplying. So to divide by 2 minus 7i, I actually have to multiply by 2 plus 7i. I have to multiply by the conjugate. Okay, so now I'm doing the dividing part or the multiplying by the conjugate part. Okay, so we're multiplying both the top and the bottom by 2 plus 7i. Okay. So here in the numerator now, I'm multiplying the 10 plus 28i times 2 plus 7i. And I'm going to go ahead and just distribute. So I'm working in the numerator right now. That's going to give me 20 plus 70i. Then I'm going to distribute the 28i. That's going to be plus 56i. Now this one, I have to do 28i times 7i. I don't know what that is offhand, kind of a big number, so I would just use the calculator to multiply the 28 times 7, which is 196. And I know that's going to be 196i squared. Okay, let's simplify the I part and combine like terms. So the I squared here, remember I squared is -1. So this last term here in the 196 times -1 becomes a -196. And now that -196 can be combined with the 20. And so that gives me a -176 for the number part. And then if I combine the I part, 70 plus 56, again, if you don't want to think about it, you can just always add on a calculator. 70 plus 56 is 126. So that would be plus 126i. Okay, so that's our numerator. So I distributed and got -176 plus 20 plus 126i. Now let's do the denominator. Okay. So in the denominator here, I was multiplying 2 minus 7i times 2 plus 7i. So I'm going to distribute. That will give me 4 plus 14i. I also have to distribute the -7i. So that's going to give me minus 14i and minus 49i squared. So we have 4 plus 14i minus 14i minus 49i squared. Simplify the I squared part, which is -1. So this one would be a -49 times a -1. Remember, they're multiplied. So this would become a +49. So I can then combine the 4 and the 49. It's 4 plus 49, so that would give me a 53. And then if I combine the I part, a +14i and a -14i add up to 0. Okay, so that means in the denominator, my answer is just 53. So here's what we end up with for our final answer. -176 plus 126i over 53. Okay, so this one, notice the numbers are quite a bit bigger than the ones we've seen because we're doing more operations. So first we did the multiplying and got the 7 plus 22i. Then we added and got 10 plus 28i, and then we did the dividing. Okay, so in order to simplify this, we did actually 3 operations: multiplying, adding, and dividing. So if you could do something like this, you would definitely be highly proficient. Okay. So let's take just like a quick stretch break. I know we've been sitting here for a while. I do want to come back and do one practice problem like this. And then I also want to give you time to try or to start on an assignment. So I don't want to spend too long. Let me get a timer. So maybe let's just take like a quick, let's say a 4-minute break. Okay. So you can get up and stretch, you can grab a drink. Let's just take a break so that we can be ready to go for one more practice problem. All right.